So we have a picture of our oil filter, and each year the cartridge inside has to be changed. This is one type, and this is the other type. This is finer, so if you have below a 0.75 nozzle, which we'll explain to you in a minute, then you need the finer fibers to take out the impurities, such as water, dirt, etc. Most of them this is good for it. You have a gasket in there as well, fresh gasket. And I like these because then you can use these to put under the filter again when you're bleeding the air out of the filter. And so it catches the oil, and then you take this and put it in your little bucket, and all this is good. So those are the filters that need to be changed on your annual maintenance. Let's go to the other end now, and here we have our nozzle assembly. At the end of this we have our nozzle, and I'll take one of these and show you what the nozzle is. So this is the nozzle that the oil goes through. Pressure again, 100 psi minimum. Okay. So this is another filter. At the very end there, that's the little hole that the oil comes out in a spray and a select pattern. The size of the nozzles run from about 0.45 up to big ones up to 5-6 gallons. But in residential, as an OBT3, you will be working on furnaces basically with nozzles not bigger than 1.50. So how do we know which nozzle to use? Well, normally you can just take the original nozzle, and I don't know whether you can pick this up in the camera or not, but this one says 150. So that's a gallon and a half that under 100 pounds pressure will come out through this little hole. If it's a 0.50, then only a half a gallon goes through. 1 gallon, of course, is obvious. 1 gallon will go through there in an hour of running. But there are other numbers on here as well. 80 B. Now 80 is the angle that the spray comes out on, something like that. Okay, and it'll go down 70, 60, even down to a 45-degree angle. Even the odd one under 30. The other note on there, B, it means the whether it's a hollow, semi-solid, or solid nozzle. And in class, we'll explain to you the difference that makes on it. But as you can see, these nozzles are, again, color-coded. Makes it easier for you. So say you want, these are Delavan nozzles. That's upside down, but here, there we go. Delavan nozzles. There are others on the market, but these are cheaper. No, they're not necessarily cheap. They're cheaper, and as well, they're very reliable. We've been using them for years, and basically no problems with them. So they're, as I said, they're color coordinated. So the red ones are hollow, which is designated by an A. The semi-solid by a W, and then a solid with the B. Okay, and so they have these numbers on them. Suppose you want this is what you want, a 0.75. So in other words, 3/4 of a gallon an hour is going to go through here at 100 pounds per square inch pressure. It comes out at the 80-degree angle, and it's a solid. Okay. So you narrow it down quickly. You want a blue one because you know you want a solid one, and then it looks at the top. Always take it out and check to make sure that you have what it says. 0.75, 80 degrees, and a B, okay? Because I've had them get mixed up, whether the manufacturer or us switching nozzles. So therefore, you want to just double check to make sure you have the right nozzle. This is a nozzle wrench. It's a double socket. This goes over the big part on the nozzle assembly. The smaller one inside goes over the nozzle. And then you can loosen the nozzle. Take it out. And usually, you change that nozzle every year when you're doing your annual maintenance. Okay? So we'll just put it back together, get it started in there, and then finishing tightening with the nozzle wrench. When you start to use this, it might be a little awkward, but once you've done 20,000 like I have, no problem. Okay, so the other part of the nozzle assembly is the nozzle holder, okay? It's just the back part of this down to here, and then you have this hollow rod that comes up, and our pump connects onto this end here. And we'll see that as we go through our next video, breaking these burners down. These are electrodes, and they have to be positioned in a precise manner to get the proper spark for our ignition. And again, we have instruments, we'll show you those, to adjust this. But again, after you've done thousands of them, you can pretty well tell by your eye whether you're right or not. This nut will tighten it up so that it doesn't move during the course of the year. And again, with a fully charged or a new transformer, the spark across here will be solid. It'll jump out to about an inch out in front of that in order to catch the oil and to ignite it. And that's why we have the space in between, is to create the spark. The spark generates heat, which lights the oil. Okay? Now, this is the transformer that provides us with the spark. So it sits on these rods just like that. And then we have the spark across here once the burner is told to start up. Okay. So this is our transformer. These two are step-up transformers. This one, a step down, basically from 110 to 24 volts. There is a transformer in the fan timer relay, this one here, which, again, step down, takes 110 voltage, brings it down to 24 to run the our fan timer board sufficiently. It also will run our primary control for the transformer. Right? The transformer switches are here on the end. Okay. So we have this is where our 120 volt comes in. Again, color coded. That's recently they've started doing that to assist everybody. This is the old type, just two black ones. If you have two black ones, you can always hook one up to power and one up to neutral, and they can be switched. It doesn't matter which. That's but as I say, now they've color coded them to help you do that. Now, these are the older type, and this weighs, I don't know, 10, 12 pounds, I guess. These are light as a feather. So, electronic iron core transformers. These are lighter, cheaper, and they've got this plate on the bottom will come off so that you can switch them for different transformers. But the nice thing now, they've basically made all the transformers the same. In years past, they'd have, I don't know, 15 or 20 different ones. And so you had to carry quite a number of them. Some of them you could switch the plate on, others you couldn't. So it was a bit of grief from time to time. These two are step up, so they go from 110. This one will run up to about 10,000 volts, and this one will run up 12 to 18,000 volts. So this gives a stronger spark. They will withstand the dampness in a basement better. So a nice improvement. Where do we go next here on our table of contents? Let's go over here to our primary controls. And we have three here. This one and this one work with the Beckett burners. We have two types of burners here in our lab, Beckett and Riello, and we'll show them both to you in another video. This is the older primary control. You had your power coming in on the black one, and then when the thermostat said, okay, I want some heat, then the power would go out and this will be hooked up to your transformer and your motor. And if there's one on the furnace, a delayed oil valve. And then all your commons come back to the white one. Okay? There is a wiring diagram on it to help you sort things out. And as we mentioned previously, TT, thermostat, FF, your flame sensor, which we will show you now. This is the flame sensor for the Honeywell controls. This is actually the cadmium cell, and it senses light, and therefore if it sees light, it says, okay, the burner is working properly, and we can continue to run. So this sits inside this, actually it hooks up to the bottom of, let's show them, oh sorry, hooks up on the bottom of the transformer, and we'll look forward to see the light. Okay, sitting like this, sees the light up ahead. But if there's no flame there, and it's all still dark in there, then this does not send the signal back to here, and it shuts off the, it will trip and shut down the burner. Okay? A lot of information but this is to give you an idea of the parts and how they work together basically. This is one of the next generations of the primary control. Again, just two sets here which attach to the thermostat. That'll be right on this, yes, okay. Then on the back you see that there's the different, instead of just having 3 wires, we got more wires, but again, they're all color coordinated and they tell you where they go. So it's not a guessing game, you can just, you know. Up here we have the 2 connections for the CAD cell. They'll just clip in like that, and then you've got your CAD cell set to go. Got to put the other one on too, but okay. So that's how your burner starts, why it keeps running, what turns it on and shuts it off, and you have your nozzles, etc. This is also a primary control. You see it's a little different. This is a primary control for a Riello burner, but it's also the transformer. So you remember these rods that were on this, and our transformer sat on it like this? Anyway, the electrodes on this connect up in here. This is not for it, but that's basically how it sits. Okay? Excellent. We mentioned this previously. What was it? Yes, vent alarm. And that's to tell the oil man, hey, we've got enough oil in here for now, shut it down, please. This is the blast tube. This is called the nose cone. See the other nose cone? Oh, here it is, right here, biting me. So this is the other side of the nose cone. It sits on there. And you'll see the grooves, the hole openings here, little slots on here. And what this does, it allows air to go through there. Our nozzle will sit in something like this here. Okay? So we want air, but we just don't want it's being forced in there. So it's forced around in these grooves, which causes it to swirl, and this lets in more or less air as you go. So in this way, with lots of air, lots of swirling, then we get complete combustion. All right. So I mentioned the transformers. What size was that fill pipe again? 2-inch. Yes. And the vent pipe, 1.25 inches. This is the cap that would go on outside on the fill pipe. On the vent cap, a little bit different. You see these little knobs on the inside of the fill cap. They're actually a little bigger on the vent cap. That keeps it from sitting down tight on the pipe so that it allows the air to escape. Otherwise, if it was sitting tight, the air couldn't escape and it would force oil back out and all over you. So if you were the guy that was filling the furnace. Fan timer board. As I mentioned, we have the 24 volt in there to run the components in here. We have our spots here to connect up for heating and air conditioning. So as you probably know, R is for heat, W is your common, G is for your fan, and Y is for your compressor outside. The C is a common, and if you have a thermostat that a digital thermostat, you can hook it up to run off the Y and C so that you'll get power from there and you won't drain your batteries as quickly. One other thing we just want to mention here, this here basically replaces this as part of your primary control. These wires on this, these are the ones that connect up to your fan motor. The, again, color-coded, different speeds. We have your slow speed, medium, and high. This is your common. So the red, if you're having your fan run all the time, that's usually what you have it on, so that you're not using a lot of electricity, but the air is moving all the time. The blue is for heat, and the black high speed for air conditioning because it's heavier, cooler, harder to move, so you want your fan to run a little bit stronger. Again, we're going back in age here a little bit with this one. This is your belted fan control, or belted fan motor. I'll get the termination correctly. So you've got a pulley here on the end, and you would have a fan belt that would go down to the pulley on your blower fan, and in this way, when this turns, your blower would turn, shoving the air upstairs. You would adjust the blower speed. As you can see, there's an Allen screw here, and if you loosen it off, then this will turn in and out. And as you know, with your 10-speed bicycle, depending on whether you have it on the front or on the back, it will adjust your speed either higher or lower. And so the bigger this is, the smaller the blower pulley, the faster it will go. So those are the two things that adjust that. All right, let's go back to the oil tank for a moment. This is the gauge that sits inside the tank. This is the little float that moves with the oil. And as I move it up and down, you can see the actual little white bubble going there. And that way, you can tell how much oil you have in your tank. Most customers, oil customers, are an automatic fill, and the oil company is able to determine through a method they have, what they call degree days, how much oil you're actually using. And surprisingly, it's very, very accurate and works well for them to do an automatic fill. Coming back to our burner, this is our pump. This is the pipe that would go up and connect to, as we mentioned, our nozzle assembly. So the pump has different parts on it, and it's nice that they have some direction here. So they give you the direction that the pump is turning. They give you the, of course, the model. They give you how much it will pump, and depending on the pressure, how much oil will go out. But they also tell you this is an inlet. If you take this out, you can put the oil in there, or you can put the inlet down here at the bottom. Depending on where your oil line is coming and on your burner, how much access you have to it. The other one down here is a bypass, a return bypass. Now, it will come without a plug in there to make it a two-pump system, or a two-line system, sorry. So if you want to have two lines because your furnace is quite a bit higher than your tank, then you have to put a Allen screw in there that they provide with the pump, and then you put a fitting on there, and the excess oil will go back to the tank. This one here is a bleeder valve. So if you get initial startup, you'll have air in the oil line, you'll have air in the pump. So you just loosen this off about a 1 turn, and start your furnace up, and once the oil starts to come out of here without any air in it, then you close it off and your furnace is ready to go. Where do we adjust the pressure on the pump? That's with this slot screw right here. Turn it in, more pressure, turn it out, less pressure. Again, the minimum that you can run a pump at is 100 psi. What's this rod sticking up here? This one doesn't have it. That's for your delayed oil valve to sit on. Okay. So your solenoid sits on there and doesn't allow the oil in for the first 10 to 15 seconds that it is running. Okay. This is the shaft in the pump, and we have a shaft here on the motor. You can see it there. So this on your burner will sit like this, and then there's a coupling that goes in between. Unfortunately, I don't have one here today to show you, but we'll show you when we do the next video and take the burner apart. This is our little blower fan that will provide combustion air for our flame. You will notice both on the pump and the shaft on the burner, there's a flat side. And the coupling has a flat side on it as well. So therefore you put the flat side on here and the flat side on there. And this will prevent the coupling from shifting, and you'll get your pump to run correctly at that time. So as we said, this motor turns at 3450, and so You hear that noise? If this blower fan is not put on properly, if that was going at 3450, all you hear would be a screech. And of course, then your customer is not going to be happy. So inside, Allen screw, a little hole there to it, so you can put your Allen wrench in there. You loosen it off and just raise it up a little bit. You don't want to go too far, or otherwise it'll hit the other side of the housing and you're back to square one with a lot of noise. Okay. We're good? Yes, okay, thank you.